this is Tanya Rowling. I'm back with another video. Do watch my other videos as well. I would be teaching CBSE Class 10 Maths NCERT Syllabus and my sister Tina Lofus would be teaching CBSE Class 8 Maths NCERT Syllabus. Alright, now let's get into the video. Today we are going to be learning exercise 1.3 first question. So today we are going to be starting off with a new question, that is, prove that root 5 is irrational. So this question is really important, and that too in this exercise 1.3, whatever questions are there now, those questions are really important. Please listen this carefully because this is somewhat difficult and it's somewhat big, okay, but don't worry, when you understand the sum you guys can solve it, okay. So here they had given root 5 is irrational. First of all, whenever they are giving root 5 is irrational, first of all we should assume root 5 is rational, okay. For solving the answer we write root 5 is rational. Now let's write that. So we wrote, let us assume root 5 is rational number. First of all, do you guys know what is a rational number? So rational number is in the form p by q, where p and q are integers and q is not equal to 0. Okay, that is the definition for rational number. First of all, now let's write, therefore, let's write root 5 is equal to, we shall write the rational numbers, that p by q, okay. It is in the form of p by q, am I right? So we shall write p by q, where q is not is equal to 0, okay. It is not equal to 0. Then what about p and q? Here we are going to be taking p and q are co-primes. Okay, now we wrote, therefore root 5 is equal to p by q, where q is not equal to 0. Why did we write this? First of all, we wrote root 5 as it is, and why did we write p by q? That's because we assumed root 5 as rational number, okay. So for that, rational number means it is in the form of p by q, where q is not equal to 0. That is the definition for rational number. So we took the form, that is p by q, where q is not equal to 0. So whenever we are taking rational number, we should write this form because the rational number form is p by q, okay. So we are taking where p and q are co-primes. Co-primes. So this is somewhat new, am I right? We know what are prime numbers, but we don't know what are co-primes. Now let's talk about co-primes. I had already uploaded what are co-primes, but still in this video I am going to be giving a short explanation of co-primes, okay. So for example, we are taking two numbers, that is 2 and 3. So when you take a LCM, for example prime factorization method, okay, you are taking 2 and 3 by using prime factorization method. So I am taking 2 and I am taking 3. So here 2 is a prime number, that means we should use prime number itself, that is 2. So 1 2 is 2. Finally we got 1 and we shall stop it. And then here we have 3. 3 is also one prime number. So we can use third table because 3 is a prime number. And then we shall write 1 3 is 3. So what is the answer? So the answer is 2 and 3. So for LCM of 2 is 2 and LCM of 3 is 3. So now we shall write, we got answer as 2 and for 3 we got answer as 3. Suppose in this question they are asking us to find the LCM and HCF. So as you guys know how to find its LCM and HCF, by using in exercise 1.2 we studied in the second problem and third problem how to find the LCM and HCF. I hope you guys remember those. So in that we found HCF by finding its common number. So here we don't have a common number, here also we don't have a common number. Then what are we going to do? We don't have a HCF. So what we do is, so we take 1 into 1. We write 1. So this 1 is known as co-primes. Okay. So when we don't have any HCF, we take 1. So that 1 is co-prime. Okay. So now HCF is, so here what are the common numbers? Here we have 1, here also we have 1. So this is a common number. Okay. So HCF is equal to 1. And what about LCM? So LCM, we take 2 into 3 into 1. So we are taking 2 as it is. So here we have 2, 1. Am I right? So instead of taking 2, 1, we shall take 1. Okay. Only 1, 1. That's because both are common, right? If we take 2, 1 also, no problem. If we take 1, it is much more better. Why? Because instead of taking 2 numbers, that is 1 and 1, we can take only 1. Okay. So I am taking only 1 because both are common numbers, and into I am going to be taking 3 as it is. So 3 2s are, it is 6. 6 into 1, it is 6. So answer LCM is equal to 6. So whenever you don't have a HCF, we write into 1. So that 1 is a co-prime. Okay. Remember, the 1 is a co-prime. So that is known as co-primes. Okay. So guys, now what we shall do is, now we shall square it. Before squaring it, let's write the form. So first of all, we are going to be writing root 5 is equal to P by Q. Let me show that. So here you guys can see root 5 is equal to P by Q. Okay, we are going to be writing this form. Okay, and then we are going to be cross multiplying it. Now let's do that. Okay, now let's write the form. So the form is root 5 is equal to P by Q. Okay, here it is in the fraction form. That means here also it has to be in the fraction form. That means we shall put 1 down here. If we don't have any number, we should take 1. Okay, now what we are going to do is, we are going to cross multiplying it. Okay, so when we cross multiply 1 into P, it is P, and now let's cross multiply root 5 into Q. Okay, so we are multiplying root 5 into Q. This is called cross multiplying. Okay, root 5 into Q and 1 into P. Okay, now let's do that. So when we cross multiply root 5 into Q, then it is root 5Q. So root 5Q is equal to, here 1 into P, it is P. Okay, so that is root 5Q. So now it is root 5 into Q is equal to P. Okay, so we got this form, and then now we are going to be squaring it. Now let's square it. Now let's write squaring on both sides. So squaring on both sides. So what was the form? So we got the answer. Am I right? That is root 5 Q is equal to P. Okay, so we got this form. Now as we are going to be squaring it, we shall put square. So here it is whole square, because this 2 belongs to Q as well as root 5. Okay, so here it is P square. Okay, so here you guys can see the square belongs to Q as well as root 5 is equal to P square. So now we are going to be doing a thing. So this is for your understanding, so I am writing in a pencil. Okay, so here it is root 5 into Q and whole square. So this 2 belongs to Q as well as root 5. Am I right? So now what we are going to do is, we are going to be cancelling the square for root 5. So here one square I am cancelling. So root 5 means, that root means it is a square. Okay, root is a square. So we cancel this square and here one square. Okay, so now it is 5Q square. Now let's write. So now what we are going to do is, we shall write 5Q square, Why? Because the square belongs to q as well as root 5. Am I right? So when we cancel the root as well as the square that belongs to root 5. So now it is 5q square, okay, is equal to p square. Okay, now this is equation 1. Okay, now let's write q square is equal to p square, and here p into q square. So this 5, it is in the multiplication form. When it cross this bridge, that is the is equal to, when it crosses this bridge, that is equal to, when it comes this side, it is division. Okay, so now it is p square divided by 5. So here it is in the multiplication form, that is 5 into q square. So when this 5 comes this side, then it is in the division form. Okay, so as you guys know, if here it is plus, okay, plus means when it comes this side, it is minus. Likewise in if it is in the multiplication form, if it is coming this side, then it is division. Likewise we did this. So now it is q square is equal to p square by 5. So here p square divides 5. Am I right? So now let's write that. So let's write 5 divides p square. Okay, so we wrote this. Okay, now let's put p is equal to 5a. Okay, now let's write, put p is equal to 5a from in equation 1. Okay, okay, so wherever you get p, no, you should put 5a from in equation 1. Now let me show the equation 1. So this is the equation 1. Okay, so in this equation 1, we are going to be writing this form, that is 5q square is equal to p square. Here, no, wherever we have p, right, instead of writing p square, we are going to be writing 5a the whole square. Okay, now let's write the form, that is 5 into q square is equal to p square. Okay, okay, now let's write that form, that is 5 into q square is equal to p square. So this is the equation 1. So as you guys know, we should put, instead of p, we should write 5a. So here we have p, we are going to be writing 5a. So the square we should write as it is. Now let's write 5q square as it is, and then is equal to, we shall write, instead of p, we shall write 5a, and then this 2 we shall write it as it is, because here it is p square. That means we should put, instead of p, we should write 5a. Am I right? So we wrote 5a, and the square also belongs to this 5a. So here it is whole square. Sorry, okay, square, okay, whole square. So 5a the whole square. Okay, so the square belongs to 5 as well as a. Now let's write q square. So now let's write 5q square is equal to, this 2 belongs to 5 as well as a. Am I right? That means here it is 5 square and a square. So if it is 5 square, then 5 into 5 is 25. So let me show that. So 5 5s are, it is 25. That means here it is 25. So the square belongs to a. So that means it is a square. Okay. So now let's write q square is equal to 25 a square. So here we are going to be dividing the 5. So we shall divide it. You guys might ask, why are we dividing it? That's because when this 5 comes this side, then it is it becomes division. Okay, so here it is in the multiplication form. So when it come across that is equal to sign, and when it crosses this bridge, then it becomes division. That's why we are dividing it. Okay, so now we shall cancel it. So as you guys know, 1 5 is 5, so we shall write 1, and 5 5s are, it is 25. So we shall cancel this and we shall write 5. Okay, so now it is 5a square. Now we shall write q square is equal to, now it is 5a square. We cancelled it and we got 5. So and then 5 into a square, that is 5a square. Okay, now here 5 into a square. So here it is in the multiplication form. So when we get this 5 here, then it becomes division. Now let's write q square divided by 5 is equal to a square. Okay, we brought this 5 this side and it becomes division. So q square divided by 5. Okay, so now what we shall do is, now we shall get this a square this side. Okay, so we shall get a square this side, and this whole term comes here, that is q square by 5. Okay, because we should write that 5 divides q square. For that, no, it has to be in this side, so we wrote it like this. Okay, don't get confused in this. We just brought this term this side and we brought this term this side. Okay, don't get confused in this. Now we shall write 5 divides q square. Of course, here 5 divides q square, so we shall write that. So 5 divides q square and 5. Okay, 5 divides q square, and we shall write 5 divides q. Okay, so now we wrote, since 5 divides p and 5 divides q, p and q are the common factors. So in this you guys might ask, why did I write 5 divides q? That's because rational numbers, they are in the form p by q. They are not in the form p square by q square. So instead of writing q square, I wrote 5 also divides q. Okay, why? Because it has to be in the rational form. Am I right? That's why. Because in rational is always in the form p by q. Okay, that's why I wrote like this, because we need this answer, right? That's why. So that's why we wrote, since 5 divides p and 5 divides q, p and q are the common factors. So to get this answer, I wrote this also. So make sure that after writing 5 divides q square, please write this also. Why? Because here it is mentioned rational numbers. We are taking it as rational numbers, that's why it has to be q. Okay, not q square. First you write q square and then you can write q. Okay, so now let's write, it is a contradiction. Let me say what is a contradiction. So now we wrote which is a contradiction, therefore root 5 is not rational, root 5 is irrational. So now you guys might have a doubt, that is, what is the meaning of contradiction? So contradiction means, first we are taking a false statement and we are taking it to the original statement. For example, let me show that. So here first of all I took root 5 is irrational, that is in the question, and then I assumed root 5 is rational number. That's because if you want an answer, we usually take, instead of irrational, we changed it into rational. So we are just taking it in the rational state. So when we are taking from irrational to rational, we are just contracting it. That means we are changing it. First we are taking the false one. In the question it's written irrational, but in the answer we took rational. That is a false one. Am I right? That's why we took the false one, and then after solving the answer, finally we got root 5 is rational. We proved it. That means root 5 is also irrational. Okay, so by first we took the wrong statement instead of taking irrational, we took rational, and then we proved this rational number, and then if it is a rational number, then it is also an irrational number. We proved it. So we wrote, after doing the contradiction, root 5 is not rational, it is irrational. Okay, we proved that root 5 is irrational. We didn't prove that it is rational. Let me show that. So here, which is a contradiction, and we wrote, see, root 5 is not rational, it is irrational. Okay, so whatever wrong statement we took, that is rational number, we just converted into irrational. So this is the meaning of contradiction. First taking a wrong statement, that is rational, and then bringing back to the original statement, that is irrational, which is mentioned in the question. Okay, otherwise we can't find the answer just by using the irrational. Okay, just by converting into irrational. Why? Because we get only one form, that is p by q. We get p by q only in rational numbers. We won't get it in the irrational. Why? Because the form of rational number is p by q, where q is not is equal to 0. Okay, so this is the answer. I hope you understood this. This is somewhat difficult, that's because this is very important topic. Okay, if you understand and study this, you can just solve it wherever, whatever questions you get. For example, if they are giving root 3 or root 2, you can just solve it by using these methods. But instead of 5, you should put that particular number. If it is root 3, instead of 5, you should put 3 and you should solve it. That's all.